Okay, good morning. Welcome to
FamilyMath number 682b.
FamilyMath682e. So before we go on to reading Jim Prop's essay on base 3 halves, the title of that essay is, I think it's called Writing 100 in base 3 halves or Counting to 100 in base 3 halves. How do you write 100 in base 3 halves? And so before we started the essay, since yesterday we talked a little bit about base 3 halves, I'm curious how you think you would solve that problem. How do you think you would write 100 in base 3 halves? What process would you use?
Well, you could use the same way you would write a number in binary.
Okay.
You just look at a bunch of places. This would be the 1, the 3 halves, 9 1/4, 27 1/8, and so on.
Okay.
And 3 to the 6, that's 29. Well, so I'll just look at this. Since we have to find the largest one that would work for us.
Mm-hmm.
So, can I use a calculator just to see what 729 over 64?
Yeah, sure.
So 7. Oops. That's around 11. So we can go bigger. So how are we going to find the last one? Because that's going to be 3 halves to the x is less than or equal to 100.
Okay.
I can just keep going up by 3 halves each time, since this should increase faster. Once. Like that. Yeah. So this looks like it's going to be the highest we can go.
Okay.
So we'll start at the, I guess, 3 to the 11th over 2 to the 11th.
All right.
Is around 86.
Okay.
So we can get one of those.
All right.
And then
3 halves to the 11th. That's 177,147 over 2,048, and that's 86.49.
So then, oops. Well then, the lowest, then we have to figure out what we can use. So this is about 11.
Mm-hmm.
So I think that's, because it went 11 and then roughly 17.
Okay.
So it looks like we're going to have...
So this was why don't you write out your digits here on the bottom with dash squares. What's the very first digit, probably starting? Oh, wait a minute. I gotta zoom out just a hair to get the board on. So when you're writing, what power is that first digit?
So to the 0.
Okay.
And then...
Wait, what? Why did you write a 1?
1.
That's the 1's digit.
Right.
Okay, so you're going to have to make how many dashes going across?
12.
Okay. Think that's the right size? So you've got 1 there in the 11th power.
Yep.
Okay, and what's the next one you think you're going to have to use?
I think the 7th.
So I'm putting it in Mathematica just so we don't make simple errors. 100 minus 3 halves to the 11th is this, and I'm going to do it numerically also. Alright, that's about 13.5. Okay. So what digit are you going to use next?
So 2, 3, 4, 5, 6, 7th.
Okay.
Or I guess 3 halves to the 6.
Alright. So, and then, so we'll subtract minus 3 halves to the 6th. We get 2.11.
So that means that we have to go down to here, 3 halves. Oh, this doesn't make sense because we're not going to be able to write it. Although now that I'm looking at this may have been a valid way to write 3 halves, but it's not a way that you would get by counting up.
Why?
Because all the numbers in base 3 halves, except for 1, start with 2.
Interesting. Okay. So we seem to run into a wall using this idea from the integers of counting backwards.
Yeah.
And interestingly, your brother ran into the same wall. So this was also his first idea. Similar idea anyway. So let's move on to the second video and see if we can come up with a different idea.